Ladies and gentlemen, good afternoon again, and welcome with our series of interviews in the frame of the Excel Joint Undertaking Symposium 2021. Today we have the pleasure to have with us Gerhard Doell, who is the Program Manager of Funding Projects at Zeiss SMT. Gerhard, welcome.
Thank you. Thank you for having me.
So you have been working quite regularly in the Excel projects. You're working as in the value chain of the let's say lithography technology. Maybe one question to start with in the current frame of the pandemic, Corona. We all have to come to realize that the sovereignty or the self-reliance on provision of medical material is of crucial importance. And obviously in our specific sector on the ECS digital, that is reflected, and that is the same. What in the ECS sector, to your understanding, are currently some of the difficulties we encounter to get these European digital sovereignty? What is their points of attention we should, you as an industrial player should look at?
Well, Zeiss is operating in the equipment sector of the semiconductor industry, and this sector is the enabler of micro and nanoelectronics. It is the key technology for many application fields, such as artificial intelligence, autonomous driving, communication, big data analysis. And here we see a push for a continuation of Moore's law. The introduction of EUV lithography opened many opportunities for high efficiency chips with high performance at affordable costs. And European application industries, such as automotive and communication, have direct access to this technology via the foundries operating globally. The semiconductor supply chain is a global supply chain. No country has complete control over every technology element needed to make electronic components and systems. EUV is a good example for that. The leading edge foundries are mostly located in Asia. The equipment for these factories is for a large part made in Europe, and the process technology comes from the US. So we have a global interdependence of players, and digital sovereignty is achieved by leveraging our assets in this global interdependence. As Europeans, I think we should invest in Europe's strengths to stay on eye level with the competition and hold our position here. In EUV technology, we have, for example, stay ahead of the pack by continuing in making groundbreaking innovations, by making high investments, and by showing the staying power when there are setbacks. This was like this in the past 25 years, when EUV was brought into reality. Nobody can solve the problems alone. A European network of technology leaders, such as companies, RTOs, universities, is needed to be successful. In Europe, we are now reaping the fruits of the efforts of the last 25 years, which was put in EUV. With our current projects, we are setting the course for the next 25 years and will enable the technologies of the future.
You are participating often in the Excel program, yeah, often right. In and around the lithography development. But what's in for Zeiss SMT to participating in such a program? What would be the key factors that you say, well, we have to keep on being involved in the Excel or for the future in the KDT program? What's in for Zeiss to participate in our program?
As I said, this is in this kind of high technology, it's a team sport. Nobody can do it alone. So we have developed a ecosystem since the beginning of the EUV program 25 years ago. Meanwhile, we have more than 1,000 partners we are working with. And many of these partners are participating in the Excel program with us in the projects we are running there. The Excel gives us the legal framework. That's one advantage which we have. It gives a legal framework where we can operate, where we can build trust with each other. And on the other hand, it gives us the financial resources to mitigate the high risks involved. I mean, typically in our projects, we have to make decisions where we don't know whether it really will work out as we expect, or whether there will be issues to overcome. And to have this ecosystem of real world leaders, technology leaders, and the financial backing by the EU and the national states gives us a position where we can take on higher risks and also be faster in the achieving our technical goals.
Yeah. So it's an interesting angle you have to look at participating in a project, which you formulate as a risk-sharing opportunity, rather than industry going alone into this innovation or in this research. We now share the risk between, let's say, the public authorities and the private investment, the industry, and saying that let's, share the burden, financial burden of going in this kind of innovation. And second, I understand from your question is that it's all about teamwork and developing an ecosystem, a value chain around this advanced node lithography technology. Clear? Yeah. Another question I would like to work on is the ambition of the Commission to think about building a mega fab in Europe. Currently, you know very well, the semiconductor industry is facing a shortage in capacity, and the demand is higher than the supply capacity on chips at this moment in time. There are various reasons. One obviously is the lack of production capacity. There is an idea going around on why don't we build more capacity in Europe, in or related to the important project of common European interest. What, as an industry player, is your take on this?
The semiconductor supply chain is a global supply chain. And in the past, Europe has benefited from that by getting access to the most advanced semiconductors on attractive terms without investing in this technology. So this was a big benefit for European industry. In the future, the demand for leading edge semiconductors will definitely increase. For example, car makers such as VW are designing their own chips in a hardware-software co-design for their specific digital vehicle platforms. So there will be need to have access to these leading-edge chips in industry which have not used such high-performing components before. Future access to this leading-edge node is therefore critical for Europe. Building own capacity is one way to go. However, this requires high efforts and high investments in fabs, in infrastructure, in the development of the processes required. And it needs also a long-lasting commitment to follow through over the next decades. Another approach is to leverage the European assets in this global interdependence. Again, EUV is a good example for that. Here, a European ecosystem has managed to develop and master a key technology for semiconductor manufacturing nobody else can do in the world. So we have a very unique position in this key technology for making leading-edge semiconductors. This position of technological sovereignty can only be maintained by further cutting-edge innovations. It will require also considerable amount of investment and a long breath to develop these key technologies of tomorrow. In supporting this, however, Excel and also KDT in the future can contribute to securing the digital sovereignty of Europe with a much higher leverage effect by investing a relatively small amount of money compared to making own fabs in Europe.
Thank you. This is, I would say, food for thought. Yeah, the leverage effect you indicate to leverage technology versus production capacity. I also understand from your reply that this idea of mega fab is a long shot. Yeah, it does require,
right,
how to say again, a long-term commitment and a long-term investment, and it cannot just be let's put once money on the table and then off you go. No, it's a very long-term commitment. So thank you for your insight in this, and maybe a final question, looking a little towards the future. We are at the moment organizing towards the KDT joint undertaking, the new program. And one of the aspects we have been working on is some kind of prioritization of certain technologies, yeah, new approaches prioritization to address the European and global challenges in our sector. A new program would allow this, yeah, new challenges, ecological, economical. What do you see as a high priority new approach or new priority for the new program? Yeah, what do you think is of priority in the new program?
Okay. The electronic components and systems are the major enabler to reach the ambitious goals of the European Union, such as digital Europe or green Europe. And here, Moore's law is still the roadmap for the economical and ecological progress of the ECS sector. Moore's law leads to more efficient chips for more complex applications at affordable cost. To give you an example, an EUV chip of today is approximately 30% more efficient than the preceding DUV chip produced 2 years ago. The effects of this performance gain in the downstream value chain will be tremendous. By the intelligent use of data, for example, from a growing sensor network, efficiency will be gained, which leads to efficiency improvements in mobility, health, communication, and agriculture. As a consequence, less resources will be consumed in all areas of our daily life. Our ambition within Zeiss Group is, for example, to operate in a carbon neutral way on a global scale in the year 2025. This is only possible when you use these innovations from the ECS sector and optimize all parts of your operations. For a future KDT program, for example, it is important to support this continuation of Moore's law. Moore's law is not dead, so to speak. It's the enabler for the future energy efficiency roadmap, which goes up to the year 2040. And we have to invest here to stay ahead of competition and make it possible in the future. On the other hand, concepts exist to reduce the material consumption in lithography and in the chip making process in the industry. We also should follow these concepts which are on our roadmaps, and implementing these in addition to the performance improvement of the chip making represents a new approach which we will go in the KDT program to follow.
Thank you. Impressive. I just want to ensure that I got it right. The continuation of Moore's law is a must to also, how to say, continue in increasing efficiency of the chips which are produced. And what you indicated is that if we compare chips from 2 years ago and now the chips produced using the extreme UV, they are 20% more efficient. That's what you indicate, correct?
Yeah, I said 30, but okay, so roughly 30%
okay, 30.
from one generation.
But that's an impressive. That's indeed an impressive progress. And if we indeed keep on going so, then obviously we will be able to bring our contribution to the greening of the ECS and the ECS for greening the rest of the European Union and community. 30 ambitious goals you set for us.
TSMC showed a roadmap this year going to 2040 with an energy efficiency improvement still going exponential for more than the next decade. Yeah. So this is still on the roadmap of leading chip manufacturer.
I think it's useful and necessary because all the electric consumption we currently have by all the digital tools is still increasing. So we have to reduce the energy consumption of all the digital tools. Yeah, we cannot keep on, how to say, spending more energy or using more energy to the continuation of these digital tools. Gerhard, I would appreciate and thank you very much for the contribution for today's interview. I think you brought interesting contribution and insights to the questions and to how the whole sector is evolving. We obviously hope that you and Zeiss SMT as a company keeps on being involved, strongly involved in the XL and KDT program, and that you will help to bring out the message on the greening of the technology and the progress needed in Moore's Law. Thank you very much for your participation in today's interview.
Thank you also. Thank you very much. Bye-bye.